Okay, so I wanted to update you before we get started. Your test over Unit 3 or Unit 2 will be on Friday. We've known that was happening for a while, right?
Unit 2?
Yeah, it's Unit 2. It's Chapter 3 in our book. Yeah, but this is the second unit for AP Calc. Yeah, this is confusing. It's Unit 2, but we're in Chapter 3, so... Friday?
Yeah, me neither.
Okay. There is already a Unit 2 review posted in AP Classroom. Multiple choice questions. Kind of give you a feel for the test, what that's going to look like. You should work on it tomorrow in class. I'm going to do a free response portion of the Unit 2 test on Monday. So you're going to have multiple choice Friday. You're going to have free response on Monday. So we're going to test Unit 2 twice. The reason that we're going to do that is because we won't get through Unit 3 by the end of the 6 weeks. And so if we're going to have 2 tests for the 6 weeks, we're going to have to test twice over Unit 2. Does that make sense to you guys? Okay, so heads up on that. That's going to be coming down the pipes. And so those of you that were absent on Friday, what you missed is the chain rule. The chain rule works for composition of functions. Raise your hand if you weren't here Friday so I know who I'm talking to. Okay, so just you three. So anytime I have nested functions, in other words, let h of x equal f of g of x. Okay, so this is a composition, so I might have an inner function and an outer function. And so when we take h prime, the derivative, we do f prime of the inner function. So the derivative of the outer function in terms of the inner function times the derivative of the inner function g prime of x. So the derivative of the outside times the derivative of the inside. It's pretty, it makes a lot of sense, okay? The problem that we run into here is we don't really recognize the outside and the inner function sometimes. Let me throw an example up here. Let's let h of x equal x plus 2 to the 8th power. Okay. I don't want to multiply x plus 2 times itself 8 times in order to create a long 8th degree polynomial that then I could use the power rule. Right, we can do better than that. And so instead, we say h prime is, we're going to drop the 8 down. So what we're looking at here is we have something to the 8th power. That's our f of x. And our g of x is that inner function, x plus 2. Does that make sense? We see the outer function is something raised to the 8th power. The inner function is x plus 2. And so if I take the derivative of the outer function, I have 8 times whatever that stuff happened to be to the what? To the 7th, right? So I take the derivative of the outer function. But then we're going to multiply by the derivative of the inside function, which would just be 1. And so our answer here is going to be 8 times x plus 2 to the 7th. Okay. I gave them peanut M&Ms so that we could remember to differentiate the peanut, which is the inner function. Because a lot of times we take the derivative of the outside, but we don't remember to multiply by the derivative of the inside. So when I say to you, don't forget the peanut, I mean don't forget the inner function. Okay. One more example that we did, we had sine of x squared. Sine of x squared. Let this be our f of x. And so f prime of x, my outside function is sine of something. My inside function is x squared. Right? So I have an outer shell and an inner peanut. And so you have cosine, and you don't differentiate the peanut in this step. We just take cosine of x squared now times the derivative of the inner function. 2x. Okay. So if you look back at the chain rule, the way that it looked when I wrote it out the first time, inside is still g of x. It's not g prime on the inside. It doesn't become g prime until we're multiplying by it at the end.
How would you simplify it? Would it be like 2x?
Yeah, no, I would just call it 2x cosine of x squared. Okay. Another one, f of x equals cosine squared x. And so you have to look at this as if it was cosine of x squared. Right? And so f prime is going to be, say it, Brooks, 2 cosine x times the derivative of cosine x, which is negative sine x. So I would say our answer is negative 2 cosine x sine x.
In the top one, is that still x squared or would that just be?
This is x squared because you're just leaving the peanut here. But we are multiplying by the derivative of the peanut. That's where the 2x comes from. Okay? Are y'all up to speed? Okay, so we'll try a new example. This is going to be example 7. This one's going to go full throttle here. So get ready. I would say get ready to rumble. All right, so here's our f of x. We have 2x plus 1 raised to the 5th power times x cubed minus x plus 1 raised to the 4th power. So here I have a product of two polynomials with powers, and both of them are going to require chains. Right? So we're going to chain rule and product rule. So let's first start with a product rule. Okay, we have a product. We're going to go first, which is going to be our 2x plus 1 to the 5th. First times the derivative of the second. And this is where we're going to chain rule. So our derivative is going to be 4 times x cubed minus 1, or minus x plus 1 to the 3rd power times the derivative of the stuff inside, which is going to be 3x squared minus 1. Did you land in that place?
Yes. And you started.
Okay. So we have first times the derivative of the second plus the derivative of the first. Truett, you want to give it a shot?
5 2x plus 1. And then that's to the 4th.
That's to the 4th.
And then times 2.
2. Good. So the derivative of the first times the second. So my second's going to have to fit right here. X cubed minus x plus 1. Okay. Now we come to the fun task of trying to clean that up a little bit. So out of the first, what I would do is I would pull this 4 to the very front. And I'm going to have 4 times 2x plus 1 to the 5th times x cubed minus x plus 1 cubed times 3x squared minus 1, close parentheses. So all I did right there was pull the 4 to the very front. Plus, and we have
Can you multiply 2 and 5 to 2 and 4?
you could multiply the 2 and the 5 and get 10. You absolutely could. So 10, open parentheses, 2x plus 1 to the 4th times x cubed minus x plus 1 to the 1st. Is it that our tail end right here? X cubed minus x plus 1. Is it still to the 4th? Oh, yeah, it should be because it was to the 4th in the beginning. Okay, so now we just have to look at each term separately. So I'm going to use a different color here. I'm going to show you this is a term and this is a term. And so we want to pull GCFs from both terms. What do both terms have in common? I would say they both have a 2. Can you tell? Because this one has a 4 and this one has a 10. So if I pull a 2, that gets me started. What else do they both have?
X squared.
Hold on. Look at the chunks. Like you got this piece and this piece and this piece. Okay, they both have the x cubed minus x plus 1. They also both have what else? The 2x plus 1. How many do both of them have as far as the 2x plus 1? What's the most that both have in common? 4. So we're going to pull 2x plus 1 to the 4th. They both also have x cubed minus x plus 1. How many do they both have of those? 3. So now, what's left from the first term? We pulled a 2 from the 4, so we're still going to have a 2. Do we have all of the 2x plus 1s from the first term? No, we left one. 2x plus 1. We left one of those. How many x cubed minus x plus 1s did we pull? We lost all of those. He still has a what, though, Brooks?
What?
He still has a 3x minus, or 3x squared minus 1. Can you see that one's left?
Oh, yeah.
Okay. Then move to the second term. We pulled a 2. So what does he have left? He has a 5. Did we pull all of the 2x plus 1s? Yes. Did we pull all of the x cubed minus x plus 1s? How many are left? Perfect. Okay. So now this is the front, and this part's the back, and now we want to push through and simplify. Okay? So on the front end, they don't want you to expand any of this. They want you to leave it as 2 times 2x plus 1 to the 4th times x cubed minus x plus 1 cubed. But on all of these that have 1 degree, let me show you what I'm saying. On all of these that have 1 degree, they want you to go ahead and push those things through. So if I have a 2 on the outside times 2x times 1, that's going to be 4x plus 2, right? That piece is going to get multiplied by 3x squared minus 1. Before we do that, we can push the 5 through here. So plus 5x cubed minus 5x plus 5. Just trying to land where the book does. Here we're going to multiply the binomials. So we have 12x cubed minus 4x plus 6x minus 2. Y'all still with me? They're not all like this. This is the worst one we're going to do today, by far. Plus 5x cubed minus 5x plus 5. And now combine like terms. Yeah. 12x cubed plus 5x cubed puts me 17x cubed. Negative 4x and positive 4x, or negative 4 and positive 6 is 2. 2 minus 5. Uh-oh.
That's x squared.
Where?
The 6. You get minus 9x.
Oh, this one. This is 6x squared. Yeah, we should have had minus 9x. So there's a plus 6x squared in the middle. And then minus 9x. Whew! I was about to get worried. Negative 2 plus 5. 3. So this is the second half of our function. And I'm just going to pull that first half down.
We have to put them together?
Yeah. Because this is our whole answer. And ours exactly matches the books. Again, if you were doing this on our free response, which I can't imagine you having to do this on the free response, but if you did, you would just do the first step and you would leave it alone, right? We lose many a problem. Good calculus, bad algebra. And so only on multiple choice are you struck with having to do this simplification and matching answers and trying to find out what in the world they did to come up with what you got on your paper. Okay. All right, let's try example 8. It's a lot nicer. Okay. From here on out, they're not bad. Yeah, that's plenty of room for example 8. From here on out, they're not the worst. So example 8 says exponential functions and the chain rule. So it wants us to find the derivative of f of x equals e to the sine x. And so for chain rule for e to the x stuff, here's what I'm going to tell you. If f of x is e to the stuff, so this is not just e to the x. Since this is not just e to the x, this is e to the stuff, whatever the stuff may be. When we chain rule this becomes e to the stuff, whatever that happens to be, times the derivative of the stuff. Okay, so we're going to do e to the stuff times the derivative of the stuff. Okay? That's our mental math right there. Okay, so yeah, f prime, it gets to make all the sense in the world to you. So e to the stuff, we're going to keep e to the sine x, but now we have to take the derivative of the stuff, which is cosine x. And so the way this comes out is you could write it, well, I think the book leaves it just like this. I always think it's more technical to put the other stuff in front, but it really, multiplication's commutative, it does not matter. So e to the stuff times the derivative of the stuff. Yay. So if it's not x, that's the rule. Okay. It could be the rule if it was e to the x, right? If f of x is e to the x. Pretend that's. So we have f prime would be e to the stuff times the derivative of the stuff, which is, see, it works. It's not a bad rule. Okay. And then we can also use the chain rule to differentiate any exponential function. So I want you to imagine that we have b to the x. This is any exponential function. This is not just the special one, e to the x. Let this be b to the x, okay? But I want you to rewrite this b to the x as e to the natural log of b to the x power. It's going to be example 9. We're working up to example 9. Okay, so why in the world would I want to write this as e to the natural log of b to the x? Because if I have e to the natural log of b, what do I really have? B to the x. But if I'll look at it this way, I can actually see what I should do to take the derivative of b to the x. Okay, so we're going to allow this to be our f of x function. Whoopsie. This is This is f of x, e to the natural log of b. Now, when I raise a power to a power, what do I do with those two powers? Multiply, right? So this is actually going to be e to the natural log b x. Just let it be. Now, it is e to the stuff. Can you tell? Okay, so its derivative is going to be e to the stuff, natural log b of x, or natural log b times x, times the derivative of the stuff, which natural log of b is going to be any number, right? It's a number. B is not a variable. E is not a variable either. I see 3 letters, but I only see one variable, and that's x. So the derivative of x is going to be the stuff in front, the coefficient, which in this case is what? Natural log b. Okay? And so we could rewrite that. Remember that e to the natural log b is just b, right? Didn't we say that in the very beginning? If I'm looking at this, the rewrite on this information is to call it b to the x. So b to the x, natural log b. That is the derivative of b to the x. Okay. So what's the rule here? We're going to just derive this one time, and then I expect you to remember it after now. So if I am given f of x is b to the x, its derivative, f prime, is b to the x natural log b. Every single time. B to the x, its derivative is b to the x natural log b. And you say, well, Arminta, how come e to the x is different? How come it doesn't behave the same way? Actually, it does. If I let f of x equal just e to the x, then I take its derivative, e to the x natural log e. What is the natural log of e? It's 1. So it is e to the x. It's itself. Okay, so it's not even a new rule. You've already been doing this rule. It's just that we didn't write natural log of e. Yeah?
Yep.
Okay. All right, and so I think this is one little quick example. It's not even example 9. It's just like a pretend like we had this on our paper. Let f of x equal 2 to the x. F prime of x is going to be, thanks, Nick, 2 to the x natural log 2. Okay. If you had a calculator and you were able to compute natural log of 2 to 3 digits, you would get 0.693 times 2 to the x. This would be your answer. I'm not going to give you time to crunch that out right now. What do you think? Not too bad? Okay, so this is going to come up a lot. We're going to have b to the x, and you have to know its derivative is b to the x natural log b. You have to know that if you're raising e to anything except x, e to the stuff times the derivative of the stuff. Questions? No, we're not done. We have 2 more examples. You got 2 more in you? Okay. I really wish Aurora was here today, because this problem makes me think of Russian nesting dolls.
We need a lot of space.
No, it's not too bad. We've got f of x equals sine
Those are also open up to each other.
of cosine.
I guess.
Yeah, the little dolls where they're stuffed inside, and they're on Toy Story, and they like pop, 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 like this. Yeah, this is this on this problem. Sine of cosine of tangent of x. So what we're faced here with an outside problem and an inside problem and then a peanut, right? So you got the candy shell and then you got the chocolate and then you got the peanut on the inside. And so we're going to chain, how do you eat a peanut M&M? From the outside in, right? Nobody except the little mice that ate my peanut M&Ms last time eats them from the inside out. Everyone eats a peanut M&M from the outside in. And so that's how we're going to attack this problem. So f prime of x, we're going to take sine, that's our first function. We want the derivative of that, cosine. And we're not touching the rest of this problem yet. So we have cosine of tangent of x times the derivative, I'm just going to write right now, d dx, the derivative in terms of x, of cosine of tangent of x. Okay, yeah. No, you're doing 2 things at once. So our first function, f prime of x, is going to be cosine of tangent of x. Now let's take the derivative of cosine of tangent of x. What's the derivative of cosine? Negative sine of tangent of x times the derivative of tangent of x. And so here in our last step of actually taking the derivative, and you could have done this all at once. I just didn't want you to have to think that far ahead. All right, so in our final step, we have cosine of tangent of x times negative sine of tangent of x times the derivative of tangent of x, which is what, Brooks? Times secant squared. It's not great. And the only thing that they prefer that you do here is, you see this little negative sign right by that sign? The negative sign by sign? You see that? They don't want that in the middle because it's very tempting to look at it as a minus, and you could see two terms there. So we want to make sure that we pull that guy all the way to the front. So our final answer is going to be negative cosine of tangent of x times sine of tangent of x times secant squared x. Final answer on this one. Okay, so a lot of times I'll get a question, how do I know when I'm done? How do I know when I have handled all of the derivatives? Well, did we take the inside function derivative? Then we're done. We don't keep going after that. You take the derivatives of the outside in terms of the inside times the next layer times the next layer. But once you're finally taking the derivative of the innermost function, that's it.
How do you know if you can't simplify?
Well, I don't know how to simplify that. That's how you know. Like, there's nothing to factor out. There's no combining like terms. We don't even have separate terms. Right? That's it. That's the answer. All right, let's try one more. This is example 10. And we have f of x equals e to the secant of 3x. So we have two inside-outer functions. Okay. Yeah. So f prime, e to the stuff. So keep the stuff. Don't do anything to the stuff. Now times the derivative of the stuff. What's the derivative of secant x? No, you're close. Secant x tangent x. Okay. We want secant x tangent x in terms of the 3x. Do you see that it's secant of 3x and it's not just secant of x? So we're going to have times secant of 3x tangent 3x. Are we done yet? Did we handle the innermost function? Multiply by 3 at the very end. Perfect. Because we need the derivative of the innermost function, which is 3x. Okay, so what's our answer here going to be? I would call it 3 e to the secant 3x. Yeah, times secant 3x tangent 3x. There's a beautiful little chain rule proof at the very end of example 10, at the end of lesson 3.6. I'm willing to skip it if you are. You need a proof in your life? Make sure that you guys have marked out number 41 from your homework assignment. Don't attempt 41. There's no reason to pull your hair out. Okay? Stay sane. Remember that there's a multiple choice review posted in AP Classroom. At this point, you've gotten through all of the notes from 3.1 through 3.6. Your test will cover all of it. So be ready to go. Deal?
Yep.
Alrighty.